Okay, so the first property, if two segments from the same external point are tangent to a circle, then they are congruent. So let's label that on the picture there. Two segments coming from the same external point. That's what it's showing right here. AB, CB, external point, point outside of the circle. Okay, AB is congruent to CB. Then a result of that is the second property. If a polygon is circumscribed around a circle, circumscribed just means it goes all the way around it, then all sides are tangent. Now, this picture makes it pretty clear that they are not all equal to each other. Clearly, AB, AF, those are longer than the ones at B and at C. But what it is saying is that these are tangent. They come from the same point B, so they are equal to each other. DB, EB, they are equal to each other. EC, FC, they're coming from the same external point, so they are equal to each other. A different length, but equal to each other. And then AD, AF, again, a different length, but they are equal to each other. So use different numbers of tick marks to indicate that. The ones that have 1 are equal to each other, the ones that have 2 are equal to each other, and the ones that have 3 are equal to each other, but different lengths. Okay, let's do a couple of examples from that. Let's look at number 11. Number 11, find each value or measure, assume that segments that appear to be tangent are tangent. Okay, so we've got an external point Q. So we have these two segments here. Again, assume if they appear to be tangent and they are tangent. So we're going to assume that they are tangent. So those segments, those tangent lines are equal to one another. So 14x minus 13 is equal to 8x plus 5. Solve for x. 6x minus 13 is equal to 5. So then we add 13 to both sides. 6x is equal to 18. Divide by 6. X is equal to 3. Did they ask us for x? No, they asked us for PQ. So we need to plug that in. 14 times 3 minus 13. I'm just going to use my calculator. 14 times 3 minus 13. 29. PQ is 29. Now, if you really want to be thorough, plug it in RQ as well. That one's a little bit easier to plug in. 8 times 3 is 24. 24 plus 5 is 29. Now, I do that just to make sure that they do have the same length. It's one way to confirm whether I did it correctly or not. Okay, so again, pretty simple. Two tangent lines coming from the same external point, they're equal. You just got to use that. Let's look at number 12. Find SV. Find SV. So let's highlight what they're asking us for. SV is that segment in the middle of this diagram. It's not labeled with anything. It doesn't have a variable in it or anything like that. So let's go to where we do have variables. ST, let me do it in a different color. ST and SU are both labeled with variable expressions. Assume if it looks tangent, it is tangent. Well, it looks tangent. So those segments are equal to one another. 10x minus 41 is equal to 4x plus 7. So we solve. Subtract 4x. 6x minus 41 is equal to 7 plus 41. 6x is equal to 48. Divide by 6. I'm not going to do what I did this morning and say that that was equal to 6. It's equal to 8. 48 divided by 6 is equal to 8. Now, we still haven't found the answer. They want SV. That's just x. Well, once we know that, we can plug it in, right? 10 times 8 is 80. 80 minus 41 is 39. I want to confirm that. 4 times 8 is 32. 32 plus 7 is 9. Okay, so we're good there. But that's still not what they want. They want this segment right here in the middle. This is going back to a problem like we had on the front. We haven't used that 17 yet. Here's where we use it. Leg squared plus leg squared equals hypotenuse squared. SV is our hypotenuse. Now, don't let that confuse you that I use those two letters. And say, if you want to use an X, use an X. Okay, you're not going to square the S and square the V. It's just representing that segment in the middle. So 39 squared plus 17 squared, 1810. So we take the square root. So 42.544 is approximately our segment SV, which is what they're asking us for, which is the hypotenuse. So it should be longer than both the legs, and it is. The longer leg is 39. 42 is obviously longer than 39. So that checks out. Any questions about anything that I did on that one? Because that was definitely multi-step there. Just putting together new idea with idea we just learned a few minutes ago. Okay, let's look at number 14. Okay, number 14, find the perimeter of the quadrilateral PQRS. Okay, so this is using that second property, that if they come from the same external point, they are equal. So I'm just going to start top left corner. That's where I usually go. If this little piece is 23, then this piece is 23. If the whole side is 37.5, how about we do 37.5 minus 23? 14.5. If that's 14.5, then this is also 14.5. They labeled the 27.1 there, so that's also 27.1. 52.5 minus 27.1. 52.5 minus 27.1. 25.4. There and there. So we have found the length of all those little segments. It wants the perimeter. Perimeter is the sum of all the sides, right? So add them all up. Now, let's be smart about this. We have two 23s, so 23 times 2, plus 14.5 times 2, plus 27.1 times 2, plus 25.4 times 2. Now, you could, of course, if you wanted to just add those all up, that's fine. I'm just trying to save myself some keystrokes. Okay, so the total is 180.